Greetings, class. This is Dr. York-Hammons. We're covering information from Chapter 7, Section 4 about testing a hypothesis that depends on a value for a proportion. So the section says hypothesis test for proportions. Now, we need to verify that we will be able to use a Z distribution or standardized distribution to test for p hat, or our approximation to the population proportion p. And one of the conditions, if you remember from the binomial distribution, if n times p is greater than or equal to 5 and n times q is greater than or equal to 5 for a binomial distribution, then the sampling distribution for p hat is approximately normal with a mean of the sampling distribution equal to p, and a standard error of standard deviation of the sampling distribution, or standard error for p hat would be the square root of pq over n, or p times q divided by n. So when we talk about doing this particular type of hypothesis test, I'm trying to get this thing to scroll down a little bit, we have to verify that the sampling distribution of p hat can be approximated by a normal distribution. And all we have to check is that n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Check for both of those. And then we can use z values, or the z distribution, and do a z test statistic for p hat. Find the standardized test statistic for p based on p hat and p times q divided by n. We can also run these using stat crunches, which is pretty much what I'll be doing in the exercises today. So we're going to look at some of the homework exercises for this section. And we're in section 7.3, which my file is not opening. There we go. Or 7.4, I'm sorry. And the exercises are here. So let's just look at number 3. It says, determine whether a normal sampling distribution can be used, and if it can, test the claim about the population proportion p at the level of significance alpha. So if we look at number 3, it says p is, where the claim is that p is less than 0.12, or the mean proportion is population proportion. I'm so sorry. The claim is that the population proportion is less than 0.12. Alpha is equal to 0.01, and the sample statistics are p hat equals 0.10 and n equal 40. Well, to verify that we can even use the normal distribution, we have to verify that n times p, which would be 40 times 0.10, that's equal to 4. Well, that's not greater than or equal to 5. It has to be at least 5 in order for us to use the normal distribution. So for number 3, we can't run the test because the normal sampling distribution can't be used. So let's check another one of these. Let's look at number 4. The claim is that the population proportion is greater than or equal to 0.48, alpha is equal to 0.08, and the sample statistics are p hat equal 0.40 and n equal 90. So I'm going to clear my calculator, and I'm going to take n times p, 90 times 0.40, and I get 36. So I know that n times p is greater than or equal to 5. Now I need to do n times q. Well, n is still 90, but remember that q is 1 minus P. So I know that Q is 0.6, and when I multiply that, I get 54, which is greater than or equal to 5. So for number 4, I can actually test this claim. So what I'm going to do is I'm going to move my book over, and I'll get StatCrunch up here where we can test this particular claim. See if we can see it a little better. So for number 4, the claim is that P is greater than or equal to 0.48. Well, since it has the greater than or equal to, I know that that is my null hypothesis. So I'll go ahead and open that out so you can see the entire hypothesis. Now, the complement to that would be HA. Apologize, I forgot to put my P in there. Okay, and then HA would be that P is less than 0.48. And it's important to remember that our H sub O, or our null hypothesis, was the claim. So I'm going to identify that. Now, when I run my test, I have to do a proportion stat. So I go to stat, proportion stat, one sample, with summary. Now, with the summary, it wants the number of successes and the number of observations. Well, we know in this particular problem, so we know in number 4, this particular problem, that P hat was 0.40 and N was 90. So if I want to know the number of successes, I'm going to have to use my calculator. I did this before. 0.40 times 90. And I got 36. So out of those 90 observations, 36 of those would be considered successes because that was your p-value. So the number of successes was 36, and I got that by multiplying 90 times 0.40, 90 times 0.40. Now I am doing a hypothesis test, and the p-value here is 0.48. That was from number 4, P greater than or equal to 0.48. So my H sub A is less than. I know you can't change the sign here on your null hypothesis, but you can do the drop-down list to get the appropriate one for your alternative hypothesis. And since my null was greater than or equal, then my alternative has to be less than, and this is the less than. And I'm going to store this in a data table. So I'm going to click compute, and when I do that, I still need to move it over just a little bit so you can see the results. I have a z-test statistic of negative 1.519, and I have a p-value. So I could use the p-value if I wanted to. Remember that in problem 4 it said alpha equals 0.08. So alpha equals 0.08, and my p-value equals 0.06 to 2 decimal places. And you can see in this case that P is less than alpha, and what that means, when P is less than alpha, that we reject H sub O. Now, if we reject H sub O, that means that we reject the claim, because H sub O was the claim. So there is enough evidence, see if I can get this typed in, there is enough evidence. Go ahead and try to make this a little bit bigger so you can read it. There's enough evidence at the 8% level of significance, because that's what we had for alpha, to reject the claim. And we knew that because we compared our p-value of 0.06 to the alpha value of 0.08. Now we could also compare it to our test statistic if we needed to find the rejection region to compare the test statistic. So we would need to find the critical values for a normal distribution. This one was less than, and we wanted it to be alpha to be 0.08, and that would occur at negative 1.405. So Z critical is negative 1.405. And if you look at our Z statistic, our test statistic value, it's negative 1.52. Well, if this is negative 1.40, negative 1.52 would be just a little to the left of this in the rejection region. It would be in this red area here. And so since Z sub C is, since our test statistic is less than our critical value, that also tells us that we reject. So since our Z test statistic, negative 1.52, is less than our Z sub C, that says that you reject the null hypothesis. So there's actually two ways to check this. You can either verify with the p-value, or you can use the rejection region from your distribution and compare your test statistic to the critical value. And again, our critical value is negative 1.41, and we wanted to be less than, our H sub A was less than, so we had to use a less than to get to the left-tailed. I realize that only got us through one problem, so there will be a part 2 for Chapter 7, Section 4. Thank you very much.